The Cabaret of Dangerous Ideas is a fantastic initiative by Beltane and the public engagement universities of the University of Edinburgh to bring their academics out to speak to you, the public. Now tonight's subject is very thought-provoking and just a wee bit on the scary side. So, without further ado, perhaps we should find out the truth about a virus to end humanity.
Ebola cases in West Africa approach 9,000. The authorities in Mexico are taking emergency measures to tackle an outbreak of a new kind of swine flu.
The latest on that dangerous Zika virus is spreading out of Florida, where the governor has declared a state of emergency.
In a city of 1 million, almost 50 new cases are reported every day.
The disease spreads to more than 30 countries.
The World Health Organization says level 5 is a strong signal that a pandemic is imminent.
Global emergency or a global health scare leading to global panic.
Good evening, ladies and gentlemen. I'm afraid that I've got some very unfortunate news, so please listen very carefully. I'm afraid that this theatre has been quarantined due to the discovery of a new infectious disease. Now, all we know so far is that this disease is caused by a virus, and this has been named the Fringe virus for now. So this means that nobody is allowed to enter or leave this room for fears of further contamination. And I can assure you that this is not just a cheap way of making sure I don't get walkouts during my show. So my name is Dr. Liam Brierley, and I'm an epidemiologist at the University of Edinburgh. Now, it could be argued that we've had a lot of near misses in the last 20 years. We've seen some viruses come into humans that have spread really very quickly, but they haven't actually been that nasty. Or we've seen some other viruses that have turned out to be deadly, but they didn't really spread that far. So it's really important to understand how dangerous our fringe virus might be. And to do that, I brought along a very, very technical piece of scientific equipment with me. This is the dangerometer. Yes. So I'm going to open a scientific investigation here, and we're all going to investigate together. We need to know where this virus came from. We need to know whether it's spreading, and we need to know what we can do about it. And as we find out this information, our virus is going to start down here, and we'll gradually see how far the risks to humanity go. Will this be the end for us? So we need to find out which animal species the fringe virus came from. To do that, we're going to need a really complicated computerized model. We're going to need some of the most advanced computing power and some of the most complicated artificial intelligence available to us in Scotland. £9 a ticket does not buy you this. So we're going to have to use this. So in here, I've got a really, really good simulation of how our fringe virus first got into humans. And I obviously need somebody to enter the simulation. So Susan,
That would be me. Yes.
would you be willing to give this a go?
Thank you. Thank you. Okay. Thank you. Thank you.
Okay, Susan, so you're gonna leave our quarantine zone for a moment,
Okay.
and you're gonna take a trip to a remote tropical forest.
Oh, lovely.
So actually, most viruses do originate in the tropics. So if I give you this, do you want to just...
I've got to put this on my head.
Yeah, enter the simulation. Okay. The air is hot and humid. You can see trees and thickets all around you. Bear with me.
It's quite dark.
It's at night.
Now I get it.
And it might even be 20 miles walk to the nearest doctor, let alone a hospital. So you might be in this forest because you're, I don't know, maybe you're collecting wood, or maybe you're collecting food, maybe you're just passing through. And all the time you're going to come into contact with millions and millions of individual virus particles in the air, in the soil, in whatever you're collecting. So let's see, have you managed to get infected? No. Oh.
That's my good Scottish constitution.
Oh no, Susan, I forgot to tell you, I'm sorry. Most of the viruses in here will not actually be able to infect you. So all of these viruses around you will be coming from things like plants, fungi, even reptiles and fish. And their cells are so different from ours that their viruses just don't seem to be able to get into us.
Oh.
So let me just hold this for a moment. I'll just change a few parameters on the simulation. So you got a virus? Have you got a virus? Did you get infected? Yes, you did. You did. Yay! So I'll just take that from you. So, what we've seen here is that actually, out of all the astronomical number of viruses that could infect us, actually, it's a really rare event. And we sometimes refer to this as viral chatter. And I really like that image because it is like the noise in a busy coffee shop. You know, there's so much going on around you, but actually, very little of it is going to affect you directly. And of the stuff that does, it's probably not going to be life-changing.
Okay.
So let's see where our fringe virus came from today. It's come from a rodent. It's come from some sort of mouse or rat, possibly.
Oh, that's a rat.
That's
definitely a rat.
Tropical rat. So the diseases they carry do seem to be quite nasty. Rodents do seem to carry more viruses than other kinds of animals. And also they have a lot of contact with us. That represents a lot of risk as well, because they can live in urban environments, and they can also live in agricultural environments. That creates a very strong sort of interface by which their viruses can get into humans. And actually, a lot of these first outbreaks of rodent viruses we've seen have happened to farm workers. So as far as risk to humanity goes, rodents are quite a strong risk. So I'm going to pop this right up to here. So I've got some new information. So our new information is that this virus seems to be spread by direct contact with people. And the way that we need to work out whether the virus is spreading, because we obviously physically cannot see transmission happening. You don't see a virus jumping from me to you. So we need to look at patterns in cases. And to do that, we're going to need to understand who is infected. So Susan, are you ready?
I am.
Excellent. Please welcome back to the stage, Susan. Looking like a Pound World Scooby-Doo villain.
Watch it, laddie.
Okay, Susan, I am going to give you this very special virus detector.
Ooh, high tech.
This is very high tech. In fact, this is so high tech. There is so much science coming out of this that if you look directly into it, your brain will be overwhelmed and explode. So please don't look directly into the light.
Okay.
Okay, Susan, you want to go out there and see if there's... It is, it should be.
Okay, so I'm looking
Can
for
we knock
hands.
down the lights just a little bit?
Yep, just bring the lights down on the audience.
Yes, that's
Just put
it.
your hands out, everyone. Can you just pop your hands out? Oh, they've gone. Oh, this is a mad one. Big mad
Have
one.
we got it right? Let's focus over here then. So,
Burn the witch.
what's your name, please, over there? Christine. Okay. We can tell you're infected. We don't yet know whether this virus is fatal. But please don't panic, because I'm sure we're going to find out by watching you for the rest of the show. Now, Christine, how many people are you here with? 7. Okay, Susan, can you find how many of those people also have an infection?
Well, actually, it's 5 out of the 7.
5, it's 5, right, so that's how an epidemiologist does contact tracing. They look at who has had contact with whom and who ended up infected. And so we can use this information to calculate something called R0. And R0 is the number of infections that one infected person causes. If you get sick, how many people do you infect? So actually, in calculating these numbers, I've made a really big assumption, because I've assumed that Christine infected her contacts, and I've assumed that Robin infected his contacts. But actually, what if it was the other way around? Or what if everyone was infected by someone else? Someone who's not even here right now? So this is where we actually need maths and even genetics to properly work out who infected who. So we ended up with an R0 of, what's 803 is about, 2 2/3. So just to give you a comparison, Ebola has an R0 of 1 to 2, flu has an R0 of about 2 to 3, measles is about 6 to 7. Incidentally, there was a team that did a study of a really debilitating condition called Bieber fever. If you're not aware, Bieber fever is a condition that mostly affects teenagers. It's the condition of being a fan of Justin Bieber. And they calculated that for Bieber fever, R0 is 24. So maybe we're missing a bigger problem here. In fact, I've just had news that one of our infected people has already left the building. So our quarantine has failed. Now, Edinburgh has a very strong rail network. It has a major motorway out west. It's got a really busy international airport. And viruses move as quickly as people do. So our fringe virus could actually reasonably be anywhere else on the planet within just over 24 hours. And I'm just hearing that actually that person is headed to the airport right now, so it looks like our fringe virus is about to go global. Our only hope is that they've decided to take the tram, because that'll buy us at least 10 hours. So while we've got a bit of time, we should think about how we're going to control this. In fact, no, let's jump forward a few weeks, let's say. Let's say our fringe virus left Edinburgh and has caused outbreaks in maybe 5 major world cities with tens of thousands of cases. What can we do about it? And again, I'm going to open up here to some suggestions. I want to know what you think we should do about it. So it's okay. So invest in treatment. Yeah, let's see. Yeah. So that is a good point. So well, let's say treatment. So who thinks we should treat people? Put your hands up if you think we should treat people. That is not the whole room. You are horrible. So treatment is obviously a good idea, but yeah, you're right to say it's going to take a long time. If this is a new virus, there's no guarantee that an off-the-shelf drug is going to work. Maybe if it's related to something that we've already seen, or maybe if it's some variant of something we've already seen, we might be able to find a drug that works. But for a lot of new viruses, and in fact for a lot of viruses that are existing today, we don't have a specific treatment. We just offer supported care.
We've got another one here.
Mm-hmm.
Identify groups who are more at risk so that you can control their behaviour as a priority.
Okay. Do we like the idea of identifying groups at risk? Nobody's given any bad suggestions so far. It's really difficult.
I know, but what are you going to do with them? Send them all out to Inchcombe Island or something?
Identifying groups at risk, yeah, that can help us target things like treatment. That's another point I didn't say about treatment. Who should get it? Because we might think originally, should we give treatment to maybe people who are a little bit older, maybe people with suppressed immune systems, because they're going to be at most individual risk. But of course there's an argument then, should we actually reduce population risk instead? Should we give it to people who contact people the most, like nurses or people who work on public transport? Should they preferentially get the treatment? And if supplies are limited, then that's a tough decision that someone has to make. I think those decisions had to be made back in 2011 with, you remember, with swine flu. There were a lot of shortages of Tamiflu, which is an antiviral drug in a lot of places, so it had to be really carefully regulated who it was given to.
Shut down transportation links, airports, rail stations.
So close borders?
Not necessarily borders.
No,
isolating cities so that if people are contaminated, at least they are contained and can't spread out into wider populations.
Okay, so do we like that idea? Do we want to vote for that? Hands up if yes.
Build a wall.
Yeah, quite a few people are liking that. It's almost like 52-48. It's the only political joke I do.
Oh, well done.
I think some people were in favour of that, and actually, I don't think that's the right thing to do, because it generally doesn't work, and it doesn't work for 2 reasons. One is that viruses always have a head start on us, and that's because a lot of them have this incubation period. So imagine 2 viruses, A and B. Virus A I get, and I'm sick straight away. What am I going to do? I'm going to stay at home, probably stay in bed, certainly I won't go to work. But virus B, let's say I get and it makes me sick a week later, I'm going to be walking around, I'm going to be getting on the bus, I'm going to be going to work for that week before I become sick. And if I'm spreading the virus during that time, that's going to be a lot more of a better evolutionary strategy. So a lot of viruses have evolved this incubation period. And what this means is that if you're trying to close transportation systems to infected people, chances are a lot of them will have already gotten through. And just to even things out a bit, closing borders will take up some resources that could have gone somewhere else, so I'm actually going to move the risk back up. Well, they didn't like that, did they? We looked at where our fringe virus came from, we looked at how it was spreading, we looked at how we could control it. And today, our fringe virus failed to end humanity. It's good. I can see some people's faces that they're actually a little bit disappointed by this. Then 1 star, apocalypse did not happen. But we did get to a moderate sort of level of risk. Now that control game that I've just played with you is quite similar to maybe how we used to do things a few years ago. We'd sort of sit around and we'd go, oh well, we'll clean up the pandemic when it happens. We'll just deal with it then. It was very reactive. What might be a lot better is if we could be proactive, if we could predict and prevent pandemics before they occur. And I think a lot of governments and healthcare authorities are actually waking up to this now after the recent Ebola and Zika outbreaks. The impact that they've had has shown that we need to stop the viruses coming in from animals to humans in the first place. What we know about is only really the very top level of the surface. We've only just scratched a little bit away. There are so many viruses that we absolutely have no idea about. And it's been estimated that it would cost about 6.1 billion to sample and identify and understand the genetic code of all mammal viruses. And that sounds like quite a lot, but actually it's roughly the same amount the NHS spends on smoking and alcohol related illnesses every year. Now I'm not trying to overgo any particular lifestyle. What I'm trying to show there is that this is actually a really achievable goal. That's just money spent in this country. It's a really achievable goal and it's a really sensible goal.
Could you tell us a bit about what your main research, what virus it is that you're focusing on, what your colleagues are focusing on? Is it flu? Is it Zika?
Well, as I said, my research is really very broad and I'm quite unusual. I used to go to virology conferences and people would say, oh, what virus do you work on? And I'd say, all of them. And then they'd look at me like there was something wrong with me. My research takes the perspective of all these viruses like Ebola and Zika and HIV. We're never going to understand why they're special, why they do what they do, why they infect humans so well, why they spread between us so well. We can't properly understand that without looking at the hundreds of viruses that aren't able to do it.
I think now that we're all slightly alarmed, obviously in the event of a dreadful pandemic outbreak, I suggest we loot Harvey Nicks. Are you with me? And we set up a headquarters at the rooftop restaurant. Who's with me? Who's with me? Yeah, lovely. As long as I get the benefits counter first, okay? So that was absolutely brilliant. So a huge round of applause for him.